This video is going to run through the 4 different methods that can be used to solve quadratic equations. And again, a quadratic equation is something with an x squared in it. It's a second degree polynomial, so something of the form ax squared plus bx plus c equals 0. So we're going to just do a brief overview of these 4 methods: factoring, the square root method, the quadratic formula, and completing the square. So let's start by factoring. If we want to solve the equation x squared minus 3x equals 10 by factoring, the very first thing we have to do is set one side to 0. Factoring method only works if one side equals 0. Then we can factor the polynomial x squared minus 3x minus 10. To do this, I need to find 2 numbers that have a product of negative 10 and a sum of negative 3. Let's see, product of 10 could be 1 and 10 or 2 and 5. And if I choose the numbers 2 and 5, positive 2 times negative 5 is negative 10, and positive 2 plus negative 5 is negative 3. So I know that my factors have to be of the form x plus 2, x minus 5. If I were to FOIL this out or multiply this out, this would give me the polynomial that I started with. So x plus 2 times x minus 5 has to equal 0. The only way we can multiply 2 things together and get a product of 0 is if one of them, at least one of them, is 0. So that means x plus 2 has to equal 0, or x minus 5 has to equal 0. Solve for x by subtracting the 2, so x is negative 2, or adding the 5, x is 5. And those are my 2 solutions. X could equal negative 2 or positive 5. Here's another example. 5x squared minus x equals 12 minus x squared. The first step is to set one side to 0. Again, the method of factoring only works if one side equals 0. So I'm going to add x to both sides, and then I'll minus the 12, and that gives me 6x squared minus x minus 12 equals 0. So this time we're factoring a quadratic or a polynomial where the leading coefficient, the number of the x squared in front of the x squared, is no longer 1, it's 6. And so there's 2 different methods that can be used in this particular case. The first method, the method that I actually like, is just trial and error. So we draw the 2 parentheses. We know that if the first term is 6x squared, we've got 6x times x is one possibility, or 2x times 3x is the other possibility. There's no other options. And so we really just have to guess and see if this works. So I'm going to try 2x and 3x first. And I don't really have a reason for this, but usually I try the 2 smaller numbers first, the numbers that are closer together, and then just kind of work my way up. Again, I don't really have a reason for that. It's just my personal habit. Then I look at the negative 12, and I want to find 2 numbers with a product of negative 12. That goes in the last 2 spots. So it could be 1 and 12, 2 and 6, or 3 and 4. And again, I just have to guess. If I try the 1 and 12, then I can check, let's see, my inner terms multiply to 3x, my outer terms multiply to 24x. Somehow I need these to add up to a negative 1x. There's no way that can happen, so I'm going to try something else. Okay, how about the 3 and the 4? Let's see, now my inner terms are 12x, my outer terms 6x. There's no way I can get a negative 1x from that. What if I switch the location of the 3 and the 4? Now my inner term is 9x, my outer term is 8x. Can I get this to add up to negative 1x? Well, now I'm going to start thinking about the sign here. I need a negative 12. So one of these has to be positive and one has to be negative. And if I make the 9 negative and the 8 positive, Yeah, it does add up to negative 1x. So that means the negative goes in front of the 3. That gives me negative 9x. The positive in front of the 4. That gives me positive 8x. Yep, that adds up to negative 1x. Now, again, trial and error can take a long time. It can be a pain, but if you do a lot of these, you'll start to get a little bit faster at figuring out where the numbers go. And I have one little tip for you. If the original polynomial doesn't have a greatest common factor, so 6 minus 1 minus 12, there's no GCF or greatest common factor, then neither factor will have a common factor. And so what that tells me is when I had placed the 4 and then the 3 in those parentheses, I without doing any work, I would have known that was wrong, because 2x minus 4 has a common factor. This also tells me that the 2 and the 6 aren't going to work, because if I put a 2 or a 6 in that first parentheses, there's a common factor. So I don't even need to try that one. All right, back to solving. I've got two factors. 2x minus 3 could equal 0, or 3x plus 4 could equal 0. So first one, add the 3, divide by 2, so x is 3/2. Second factor, subtract the 4, divide by 3, x is negative 4/3. And those are my two solutions. Now, I really like the trial and error method because I think it's really fast. But if you prefer something that's a little bit more, I guess, algorithmic, or has kind of a list of steps to follow and less guessing, there is another method that you can use to factor things of the form, I guess we've got 6x squared minus x minus 12. And I refer to that as the AC method. And how that method works is you take the first number times the last number. 6 times negative 12 is negative 72. I think that's why it's called the AC method, because you're taking like the A times the C. Okay, and so then we want to find two things with a product of negative 72 and a sum of the middle coefficient, which in this case is negative 1. So 72, that could be 1 and 72, 2 and 36, 3 and 24. Wow, lots of options. 4 and 18, 6 and 12, or 8 and 9. And if it's negative 72, one of these numbers has to be negative. To get a sum of negative 1, I would use negative 9 and positive 8. So 8 and negative 9 multiply to give me negative 72 and add up to negative 1. So then what I do is I copy down the first term, 6x squared, and I take this middle term, this negative x, and I use the two numbers that I found to write it as two terms. 8x minus 9x, and then I copy down the last term, minus 12. Then I can use something called factoring by grouping, where I just look at the first two terms and see what they have in common. I can take a 2 and an x out, and I'm left with a 3x plus 4. Then I look at the second two terms. What do they have in common? I can take out, they're both negative, so I can take out a negative and a 3, and I'm left with 3x plus 4. This method works if you get the same thing in both parentheses. If you don't get the same thing in both parentheses, it means you made a mistake somewhere in the process. So then I can take this 3x plus 4 and I pull that out front, and I'm left with a 2x and a minus 3. And there's my factors, 3x plus 4, 2x minus 3. These are the exact same factors I got before, and so I can set those equal to 0. I get the exact same answer I got when I used my trial and error method. The next method I want to run through is the square root method, or sometimes it's called extraction of roots. Sometimes it's not convenient to factor, or sometimes you just can't factor a quadratic equation. The square root method is a method that only works if it's possible to isolate the squared quantity. So you can't have a squared term and then a linear term in the equation. This equation only has a squared term, and so the first step is to isolate the x squared. In this case, that means add 18 to both sides, and then divide both sides by 2. So now that I have the x squared by itself, x squared equals 9, I can finish by taking the square root of both sides. However, I will need to add a plus or minus to indicate that the answer could be positive or negative. If you square a positive or a negative number, you get the exact same thing. So there's two possible answers, positive or negative square root of 9, which is positive or negative 3. Here's another example. We've got the equation x minus 4 squared equals 25. The first step is to make sure the squared term is by itself. We already have that. So I can take the square root of both sides. Again, don't forget the plus or minus. When we take the square root of x minus 4 squared, we're left with just x minus 4. The square root of 25 is 5, but again, it could be positive or negative. So I'm left with x minus 4 could equal positive 5, or x minus 4 could equal negative 5. I'm going to write that out as two separate equations and then finish by adding 4 to both sides. So that gives me two possible solutions. X could equal 9, positive 5 plus 4 is 9, or negative 5 plus 4 is negative 1. The third method I'd like to talk about is the method of completing the square. In this method, the idea is to take your quadratic equation and get it into a form where you can take the square root of both sides. Get it into some type of form where you have just a squared quantity. And so the first step is you're going to take your constant and move it to the right-hand side. So you just want the x squared and the linear term on one side of the equation, constant on the other side. So I have the equation x squared minus 6x minus 3 equals 0. So I'm going to add 3 to both sides. Then the second step is to complete the square. To complete the square, we take the number in front of the x. We're going to call that b. So we take the number in front of the x, we divide it by 2, and square it. So in this case, the number in front of the x is negative 6. I divide that by 2, I get negative 3. I square it. Negative 3 times negative 3 is positive 9. And so I'm going to be adding 9 to both sides. So again, take the number in front of the x, divide it by 2, and square it. And what this does is it creates a perfect square trinomial on the left side. X squared minus 6x plus 9 can be factored as something squared. And then on the right side, I just did 3 plus 9 is 12. So the next step is to factor that left-hand side. So we can do x and x, and then we could find product of 9, sum of negative 6. 9 is 3 times 3. And if we make them both negative, we get x minus 3, x minus 3. This left-hand side can be factored as x minus 3 squared. And in fact, it's always going to be x, and then whatever is half of the, number in front of the x. So x plus negative 3, or x minus 3 squared. So now I have the equation x minus 3 squared equals 12. And this is something I can finish using that square root method. I take the square root of both sides and then solve for x. So take the square root, don't forget the plus or minus. On the left, that gives me x minus 3. And on the right, I get plus or minus root 12. 12 is the same as 4 times 3. 4 is a perfect square. So square root of 4 turns into a 2. And then the 3 stays inside the radical. So I've got x minus 3 equals plus or minus 2 root 3. And then finally, to solve for x, I have to add 3 to both sides. So I get x equal 3 plus or minus 2 root 3. And that's my final answer. I can't go any further with that. We can't combine the 3 with something with a root 3. Here's another example. Let's go through the exact same process. We're going to solve x squared plus x minus 2 equals 0 using the method of completing the square. Step 1, move the constant over to the right, so add 2 to both sides. Step 2, complete the square. I take the number in front of the x, which is 1. I divide it by 2, which is a half, and I square it. 1/2 times 1/2 is 1/4. So number in front of the x, divide by 2, squared. So I'm going to add 1/4 to both sides. So I've got x squared plus x plus 1/4, and then I'm going to take 2 plus 1/4. I added those numbers together. 2 over 1 is the same as 8 over 4, plus 1/4 is 9/4. So equals 9/4. Now I have to factor the left-hand side. This is a perfect square trinomial. I can factor this as something squared. It's going to be x plus the number that we squared, the 1/2. So x plus 1/2 squared equals 9/4. That works because 1/2 times 1/2 is 1/4. 1/2 plus 1/2 is 1. When you do your factoring, it's always the thing that you squared. Now we can solve by taking the square root of both sides. That gives me x plus 1/2 equals plus or minus root 9/4. In this case, 9 and 4 are both for perfect squares. So the square root of 9/4 is 3/2. Then I'm going to subtract the 1/2. So I've got x equals minus 1/2 plus or minus 3/2. This time we can go further because there's no square roots in the equation or the answer. Negative 1/2 plus 3/2, so we can do that, and then we'll do negative 1/2 minus 3/2. Minus 1/2 plus 3/2 is 2 over 2 or 1. Minus 1/2 minus 3/2 is minus 4/2. That's minus 2. So I've got answers of 1 and negative 2. All right, let's do one more with this method. 2x squared minus 5x minus 4 equals 0. Step 1, move the constant over. 2x squared minus 5x equals 4. Now before we can complete the square, the first term has to just be an x squared. We have to get rid of that 2 in front of the x squared. To do that, I'm going to divide everything by 2. So now I've got x squared minus 5/2 x equals 2. To complete the square, I take the number in front of the x, negative 5/2, I divide it by 2, and I square it. Negative 5/2 divided by 2 is negative 5/2 times 1 over 2. Let's copy dot flip, right? When you divide, it's the same as multiplying by the reciprocal. Dividing by 2 is multiplying by 1/2. So negative 5/2 times 1/2 is negative 5/4. When I square that, I get 25 over 16. So I'm going to add 25 over 16 to both sides. On the right-hand side, I'm going to take 2. Here we go, 2 over 1 plus 25 over 16. Get a common denominator. The 2 over 1 becomes 32 over 16 plus 25 over 16. That's 57 over 16. Now I have to factor that left-hand side. I can factor that as something squared. And it's going to be x, and then it's always that number that you squared. So in this case, it'll be x minus 5/4 squared. So x minus 5/4 squared equals 57 over 16. Take the square root of both sides, don't forget the plus or minus. That gives me x minus 5/4 equals plus or minus root 57 over 16. 57 is not a perfect square, that stays in the radical, but 16 is a perfect square. So I can rewrite that right-hand side as plus or minus root 57 divided by 4. Finally, I'm going to move that 5/4 to the other side. I'm going to add 5/4 to get my answer. And so my answer is x equal 5/4 plus or minus root 57 over 4. And I can leave my answer like that. That looks great. We can't combine the 5 with the root 57. But if I wanted to, I could also write it as a single fraction because we have the same denominator. So we could write this as 5 plus or minus root 57 all over 4. Both forms are perfectly fine for the answer. All right, finally, let's see what happens if we take a general quadratic of the form ax squared plus bx plus c equals 0, and we apply the method of completing the square. First step is move the constant over, subtract the c. Then I have to divide everything by a because I need that first term to be just an x squared. So that gives me x squared plus b over ax equals negative c over a. To complete the square, I take the number in front of the x, b over a, divide by 2, and square it. Dividing by 2 is the same as multiplying by a half. b over a times 1 over 2 is b over 2a. And when I square that, I get b squared over 4a squared. So I'm going to add b squared over 4a squared to both sides. On the right-hand side, I've got negative c over a plus b squared over 4a squared. I'm going to get a common denominator by multiplying the negative c over a by 4a over 4a. That gives me negative 4ac over 4a squared. And when we add that to b squared over 4a squared, I get negative 4ac plus b squared all over 4a squared. So I'm going to copy that down over to the left. But just because it looks a little bit nicer, I'm going to put the b squared first. So I'm going to write it as b squared minus 4ac all over 4a squared. Then on the left side, I have to factor the perfect square trinomial. That's going to factor as x plus something squared. The something is always whatever you squared. So in this case, it'll be x plus b over 2a, quantity squared. Take the square root of both sides, don't forget the plus or minus. So that gives me x plus b over 2a. And then on the right-hand side, we've got plus or minus square root b squared minus 4ac. And then the denominator, 4a squared, if you square root that, that turns into a 2a. Finally, to solve for x, I have to subtract the b over 2a. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. We have the same denominator in both terms, so we can write that as a single fraction. And so my solution is of the form negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have just used the method of completing the square to derive a formula that will give us the solution to a quadratic, any quadratic, of the form ax squared plus bx plus c equals 0. The method of completing the square is pretty long and can be involved, and so most people find it easier to just memorize this formula rather than using the method of completing the square every time. And this is our fourth and final method, the quadratic formula. So if I want to solve the quadratic equation 2x squared minus 6x plus 1 equals 0. Using my quadratic formula, I have to identify my formula. I have to memorize my formula. There it is. Just took it from the previous slide. In this formula, the a is the number in front of the x squared, so 2. B is the number in front of the x, negative 6. And c is the constant 1. Now, when you're using the quadratic formula, make sure your quadratic is set equal to 0. We started with that assumption when we derived the formula. And now all I have to do is just plug those numbers in. So negative b, negative negative 6, plus or minus negative 6 squared, minus 4 times a times c, so 4 times 2 times 1, all over 2 times 2. This becomes positive 6, plus or minus negative 6 squared is positive 36, minus 4 times 2 times 1, so minus 8, all over 4. So that's 6 plus or minus root 28 over 4. And I think we can simplify this further because 28 is 4 times 7. Square root of 4 is 2. So root 28 turns into 2 root 7. And then I notice that all of the terms, 6, 2 root 7, and 4, all of the terms are divisible by 2. And so I'm just going to reduce this to 3 plus or minus 1 root 7 all over 2. And there's my final answer. All right, that was my last example. I know this was a very quick overview of these 4 methods of quadratics, so please let me know if anything is unclear in this video.